we're going to take a look at a variation problem. Remember, when we're talking about variation, we either have direct variation, which is what we're going to see in problem number 20, which means we have something like y equals k times x, or we could have inverse variation, which would be something like y equals k over x. So we just have to read our problem carefully to see what type of variation we're dealing with. For number 20, it says y varies directly as x and inversely as c. So we actually have a little bit of a combination of variations here. So our problem will look something like y equals k times x, then divided by z. And then they give us a paired set of data. So we know that when y equals 9, x equals 6, and z equals 2. So the first thing I'm going to do is use that cluster of information that all belongs together and plug it into our general form to figure out what k equals. So for this problem, that would be 9 equals k times 6 over 2. Reducing here, I would get 9 equals 6 divided by 2 would be 3 times k. And divide both sides by 3 to solve for k. I get k to be 3. This means that for my specific problem, I have y equals 3x over z. Then the last part of the question asks me to use bits of information to find a missing piece. So my bits of information are x is 3 and z is 12, so find y. So I'll just plug in what I know to the formula that I've written to find what I don't. So y equals 3 times 3 over 12. So I have y equals 9 over 12. I can reduce this because both the top and the bottom are divisible by 3. So I get y equals 3 over 4.